Step 11, post-design considerations. Now in this step, I'm going to discuss the various issues that you have to consider prior to the acceptance of any smoke, heat and exhaust ventilation system. Now the first issue I'm going to consider is when you are installing free-hanging smoke curtains. Now smoke curtains themselves are used to create reservoirs which will contain smoke and hot gases. Now to carry out that role they must resist the sideways deflection caused by either, firstly you've got the buoyancy driven forces due to the hot gases, or you've got the fan induced forces in mechanical exhaust systems. Now if they do not resist these forces, gaps might occur beneath the curtain or between the curtain and the building structure, which obviously can lead to the flow of hot gases from the reservoir into your adjacent areas. And this is clearly not part of the design criteria. Now there are two types of smoke curtains, and these are, you've got fixed and you've got movable. Now movable curtains are usually designed to drop vertically in response to an appropriate signal. For example, a smoke alarm or a sprinkler. Setting off an alarm will make the smoke curtain drop. Now where these are not guided by vertical channels, in other words they're not actually guided but they are free hanging, they have to be long enough to contain the smoky gases without spillage due to the horizontal deflection caused by the hot gases. So it's not flush, they've got to be longer than this. And again, as I said before, the fan-induced pressure differentials caused by the exhaust fans. Now this is only likely to be problematic when the curtains are deep or the bottom bars are not very heavy. So in other words, they're light. The bar that actually holds them down. It's not heavy enough to hold them down. Now there has been significant research carried out by the Fire Research Centre which has shown that the existing deflection tests for smoke curtains are actually virtually meaningless in terms of actual behaviour. And it's necessary to bring smoke curtains actually into the design process. In other words, you've got to calculate beforehand how long they have to be to take into account these deflections. You've got to know that. Now what you have to do is ensure you specify the correct combination of curtain material weight and the bottom bar weight, so the bar itself a certain weight, to ensure that the curtain deflection remains within acceptable design limits for that particular application. Now in general, the hotter and deeper the smoke layer becomes, then the heavier the curtain and or the bottom of the bar must be. So one of them's got to be heavier to hold it in place. Now this in turn can require major differences in the components. For example, you've also got to consider that the curtain might need strong motors, stronger brakes and stronger attachments to the building itself. Now the specification of a smoke curtain which is too light for the application can result in excessive deflection, with the accompanying rise of the bottom bar and leakage of smoke quite clearly past the curtain. And you'll also find sometimes that smoke curtains which are light enough to deflect appreciably are located on the line between two columns. So you've got two columns with the curtain in line with them. This is normally for cost reasons. The problem is that if the columns are rounded, they're not going to fit snugly and they will allow leaks. In other words, they're not going to do what they were designed to do. And these are the problems that you may expect. And again, you must ensure that you take into account this deflection. Now, there has been a lot of work carried out, and it has shown that the deflection of a smoke curtain and the flow of hot gases through gaps in it can be directly related to the hot gas layer contained by this curtain. So the actual temperature of the gases. Now, the procedure to follow to determine the deflection of the smoke curtain is now going to be discussed. I'm going to go through this now. And I would like to make it clear that this is only applying to free-hanging smoke curtains, as obviously fixed curtains obviously do not deflect. So this is only for free-hanging. Now, free-hanging smoke curtains can be divided into two categories. You've got those which fall to floor level and completely seal areas from a smoke compartment. I mean, these might be installed along balconies, for example, to form a closed atrium. So it actually closes off the atrium. In effect, it has the same effect as a compartment wall. And you've also got those which act to contain a gas layer which does not extend below the bottom of the curtain as shown here. For example, you've got reservoir screens and channeling screens. In other words, they only drop low enough to maintain the smoke layer in them. That's what they do. And these would normally be designed to extend at least 0.1 metre below the calculated smoke layer depth. Now, the pressure of the hot gases acting on the smoke curtain will cause it to deflect from the normal vertical hanging position. Now, that horizontal deflection of the curtain causes the bottom of the curtain to rise, which could lead to leakage of gas underneath the curtain if the rise takes the bottom of the curtain above the base of the gas layer. So as long as it goes above the gas layer, then obviously it's going to cause leakage. Now, because the curtains are not rigid, they're also likely to bow in use. You know, like a sail in the wind in the middle, they'll actually bow due to the pressure of the gases. And this bowing will further lead to a rise at the bottom of the curtain. Obviously, as it's bowing, it's going to lift the curtain up again. Now, how do you determine the deflection of the curtain? Well, to determine that, you use the following formula. This is the formula here. First of all, you've got DC, which is the deflection of the curtain in metres, equals 1.2 times, first of all, you've got the density of the ambient air, which is in kilograms per metre cubed. You've got theta, which is the temperature arise above ambient of the gases in the smoke layer. And you've got d to the power of 3d cubed, which is the depth of the gas layer. And all this is divided by, you've got 3 times T, which is the local smoke temperature. And that's multiplied by 2 times NB, which is the weight per metre length of the curtain's bottom bar in kilograms per metre. And you've got to add that to MC, which is the weight per metre squared of the curtain fabric, which is in kilograms per metre squared. And you multiply that by LC, which is the length of the smoke curtain from the top to the bottom, which is measured along the fabric. So that's measured along the fabric. That's the formula that determines the deflection of a curtain.